Hi, this is Michael Sharp. I'm a part of Group 16 along with Kolby Fenster for the COSC310 group project. We chose to look at Case Study 2, the test specification for the GameForge project. GameForge lists their key strategies in this test specification document, starting with unit testing with white box testing methods. White box testing attempts to test the code implementation of individual modules with an understanding of that implementation. Basis path testing is an attempt to cover all executable paths of the code, while loop testing looks at identifying iterations or repetitions in the code to ensure that it's exercised in a way that any conditional elements inside these loops are found and tested with the appropriate data. Integration testing using black box testing methods. Integration testing looks at piecing together the individual modules that have been previously tested in the unit testing phase and seeing how they work and testing their functionality once integrated. Black box testing has no interest in the implementation of the code, rather the result and the functionality as described in specification documents for the project. So what we're really looking at is, does it do what it's meant to do? The text mentions this can be done incrementally. As modules are written, they can be integrated and tested, or the integration can happen later down the track. We mention incremental and continuous testing ideas later in this presentation. The validation testing using black box testing methods looks at validating the data files that are generated by this software. And again, that's purely black box testing. They want to make sure that the outcome or the output meets the documented requirements. They list higher order testing in the form of an in-house beta and a public beta release. This sees a fully integrated working system being used by in-house testing staff and members of the public. And they also intend to test their record keeping as far as the testing process goes, how they track bugs, how they store and access their testing data, and the process behind how testers can report, file bugs, defects, enhancements, etc. The effectiveness of these strategies. The unit testing approach seems quite comprehensive, assuming that the basis path testing can cover all executable calls within each module. Kolby will have more to say on how that might be further guaranteed later on in this presentation. And with white box testing, having an understanding of the implementation or how the code was written and how it's meant to behave, we also are curious about whether some sort of independent input into the testing process or writing the tests would might be seen as being more effective, having some third-party eyes on the source code rather than the people who wrote it. The integration testing listed as using black box testing methods. The text mentions that integration testing can utilize both white and black box testing methods. It may be something that GameForge could benefit from if they were to employ both of these styles of testing at the integration stage. The effectiveness of their higher order testing in the form of their beta releases seems quite effective in the way that they will get some in-house staff that have worked closely with the project and understand how it might work, as well as members of the public who might be seeing it for the first time, and it seems like a good balance, and they probably get some important feedback from both of those groups. Another alternative strategy listed in the text is positive and negative testing. And this might lend itself again to having some independent testers on board. Positive testing is testing the code with inputs that the code's meant to work with. And this is pretty common for people that write the code, who understand what it's meant to do, have a tendency maybe to use inputs that exercise the nature of the software working, whereas negative testing is a way of being able to maybe throw some trickier problems at the software. So an independent tester might be curious, or maybe through ignorance even, might be throwing some sort of data at certain routines or functions that will see the software behave in ways that someone who wrote it might not think of exercising that piece of code in that certain way. Another alternative strategy, regression testing. This is to ensure that any fixes they make along the way, fixing defects and bugs, ensuring that this doesn't break any previously working parts of the code base. We do talk later about this, and in the essay, about having some continuous testing within the build environment can ensure that each iteration of the code base, changes to the code base, make sure that tests get exercised in a timely manner. I'll pass over to Kolby Fenster, who will continue with alternative strategies and also continue on with the remaining questions.
Hello everyone, my name is Kolby Fenster and I am in Group 16. I was working with Michael Sharp on the Case Study 2 Test Specification document. Michael had just finished going over regression testing as an alternative strategy that Gameforge could have implemented. I'll be going over some more alternative strategies as well as question 4 and question 5. So to pick up where Michael left off, code coverage analysis is another alternative strategy. Code coverage analysis essentially provides reporting on areas of source code that were not executed during the running of a test suite. If you combine this with loop testing and basis path testing, this essentially guarantees that any executable code is found and tested and that you're not missing anything. The last strategy that we thought Gameforge could potentially implement is peer review sections throughout the testing phase. One of Gameforge's goals was to have understandable code, and if you have multiple people review a component, then that increases the likelihood that it's going to be understood by more people. And then you can also ensure proper documentation and conventions are being followed. This will help future team members if they have to work on this component, or anyone trying to fix a bug for the component. Moving on from the alternative strategies, Michael and I both noticed quite a few vulnerabilities within the test specification document. This first one is more of just a minor thing. Gameforge was having to develop a frame rate counter to test system performance in the testing phase, but they didn't really specify how they were going to ensure the frame rate counter worked and was accurate. Another thing was testing schedule conflicts. The testing phase was happening very late into the project, and a lot of the units inside the testing phase had very short date ranges, as well as a lot of the testing was occurring on weekends. This raises a lot of questions as our staff expected to come in on those weekends and work. What happens if a coordinator is sick or a public holiday happens, and what happens if a unit takes an additional day to complete. Moving on from there, there was the beta tester report form. Essentially, bugs and enhancements were being submitted on the same sheet, and this leads to issues of bugs being put on the enhancement side, enhancements being put on the bug side, and just making it difficult to review the beta tester reports and discerning bugs from enhancements. The last two vulnerabilities that we noticed were lack of independent testing and that no security testing was being conducted. For the lack of independent testing, it seemed that whoever was reviewing a component was often the person who wrote that component, and that's just going to make it harder for that person to find bugs and defects in code that they wrote. As well as with the security testing, you never know if changing the source code or operating environments is going to introduce security vulnerabilities that you never even thought of. So not testing for security issues is a big deal. So with all those vulnerabilities being pointed out, we came up with a variety of solutions. The first, for addressing the frame rate counter, they just need to test that beforehand it works and is accurate. With the schedule conflicts, we thought that they could dedicate more resources to testing phases so that each unit gets completed faster, and then, or even just start testing earlier in the project. If none of those are achievable, potentially they reduce the length of the public beta from being over a week to maybe just a week or 4 or 5 days. With the beta tester report form, we said that they should create 2 separate reports, one for bugs and one for enhancements. This will help the person who is reviewing the feedback, as they can easily discern what's a bug and what is an enhancement. For the lack of independent testing, we kind of covered this in our alternative strategies. We suggested peer code review sessions, and that way multiple people are reviewing components. And then with the security testing, they just need to schedule time within the testing phase to conduct security testing. Moving on to the last question, we just wanted to note that the textbook states the inclusion of testing techniques is a best practice, while skipping quality assurance is a huge pitfall. This essentially means that if your testing phase is starting to drift off plan, your project is probably going to suffer. Luckily, we provide solutions to deal with this. To start with, if the schedule for the testing phase is starting to drift off track, there are a couple things you could do. I mentioned earlier that the public beta goes on for over a week, and if you need to make up lost time, you could probably shorten that beta to 4 or 5 days. If that's not going to help, you could always include more automated testing strategies within your integration and unit phases. This should free up more resources to conduct alternative testing that maybe doesn't lend itself well to automation. If the budget is starting to drift off plan, currently one person on the development team only has to review like one part of the testing phase. You could now have them start reviewing multiple phases. If that's not an option, you could just tell your testers to conduct less thorough testing, or just release the software with known bugs and issues, and hopefully be able to release a patch at a later date. Lastly, if the deliverables for the testing phase are starting to drift off plan, you could always just have a meeting to exclude certain features of the software that are proving difficult to test, as long as they aren't going to take away a key requirement of the project. With these features, you could also just exclude them until you have a chance to test them, and then later release them as part of an update or a patch. Ultimately, I hope you guys can see how that GameForge takes quality assurance pretty seriously, and that their test specification document was pretty well detailed. That being said, we think the suggestions and observations that we made can make the test specification document from one that elevates a project's chance of success to one that almost ensures it.